Okay, it's 12:15. We can now start with the lecture again. So I think I've stopped with the sewage treatment plant. So for your STP, it differs from your septic tank because it produces a clean and polluting effluent which can be discharged directly to a stream, ditch, or other water course, or to a soakaway for dispersal into the soil. And then it requires electricity for the process, especially since you have a pump, okay? Or because your wastewater treatment facility is located at a higher elevation than the service area. So, it requires an actual servicing. So, kailangan may magtao, there should be manpower to ensure that your wastewater treatment or your sewage treatment facility is really working. And then it has to have a large surface area in contact with the air. So some aerobic digestion will now take place. Compared to your septic tank that is anaerobic, kailangan for your STP, it should be aerobic. And then it requires emptying intervals between 3 to 60 months. And then effluent can be discharged to a receiving body if it will pass the requirements. So that is the main difference between your septic tanks and your sewage treatment plants. Okay, so for the design of an STP class, you have to pay attention this time because this will be your final requirement. I will finalize what you need to do later on and then I'll send in your canvas. But for now, I need you to listen so that you'll know what to do with your plate, okay? So for example, you have the location of your project that is in Barangay Pinsao proper, Baguio City. I don't have a picture of Barangay Pinsao. I'll show you later on. Okay, anyways, I'll give you a study site. I would be the one to indicate where you are to put your STP, for example. So first things first that you need to determine is the total lot area. You can do that one if you have your Google Earth, a simple calculation, a measurement of your area. You can do that in Google Earth. Or if you know how to make use of your GIS or your Geographic Information System, then that can be too. So, ito pala ang gagawin sana natin. If it was face-to-face, I will teach you a simple GIS application of your sewerage and drainage. But because we are offline, okay, I cannot demand that you learn how to make use of your GIS. Anyways, so population in 2010 was 5,257 people or persons. And then the growth rate is equal to 0.0256. And then the economic life of the project is 20 years. So it's up to you as the designer to put how many years you would like your STP to run. And then the start of the operation. So let's say that the start of the operation, taking into consideration all of the construction and then obstructions in the construction, okay, and everything. Okay, we start at the year 2015. And then the termination or closure of the project will be in the year 2035. So, we have a detention time here. Your detention time is defined as the time by which your wastewater will now enter the treatment facility until it leaves your treatment facility. That is your detention time. So let's say that the detention time is 2 hours and the lifespan is equal to 25 years. And then the per capita sewage contribution is equal to 150 liters per day per person. You can all find this in a table in a book called by Metcalf and Eddy. That is your wastewater treatment design. I'll give you access to that book. It's not really a legal copy, so I need you to download it fast because I will remove it. Okay? Baka makasuhan ako klase. But I'll give you the book so that you can use it. Okay. So for the computations, first thing is to forecast the population from 2010 to from your 2010 to 2035. That is the start of the service of your STP. So you're given here the formula for geometric method for forecasting your population. So PD is the forecasted population. So that is P 2035. And then that is equal to the present population. And then multiplied by 1 plus R. R is equal to the rate of geometric progression. Okay. And then N is the number of years. So let's say that P2035, you know the population in 2010, that is 5,257 that is given. And then you're also given R here a while ago. Okay? The design is 25. Do not use 20. Okay? Kasi what we are trying to find out is the population by the year 2035. It's not the service life of your wastewater, of your sewage treatment facility. Okay? So what we are to determine is the population by 2035. So use 25 years. So I'll erase. Okay. By computing this value, you get a projected population of 9,890 persons. Okay, take note. So if I know how much people would now be in Baguio City or in Pinsao proper, Baguio City, by 2035, I get 9,890 people. Then, oops, wait lang class. I'll have to move this one. Okay. Then, by using, asan na yun? Okay. The per capita contribution of each person, okay? Then I know the design flow. I need to move. Okay, wait. It's here. Ayan. And then, okay, for your dry weather flow, please remember the number of persons a while ago. And then for your dry weather flow, you are given the per capita contribution of the per capita contribution that is 150 liters per person. And then, oops, pakipalitan to class, I'm sorry, should be 2035. I'll correct when I'll give you the copy. So this should be 2035. And then you're given the PCSC or the per capita contribution. Okay, we have computed this one a while ago using your geometric progression. And you get 9,890 people. And then afterwards, you get the dry weather flow in liters per day. So I want it in cubic meters per second or cubic meters per day. You just have to convert and you get 1,483.5 cubic meters per day. Okay? So walang mahirap dito class. All you have to do is multiply and then convert your units. Okay, so after finding for the discharge, this is now the contribution, sanitary contribution of the population by the year 2035. 2035. So you should design your sewage treatment plant to service this flow. Okay? So dapat ito yung kunin mong flow so that you can now take into consideration the population growth in 2035. Do not use the 2010 or the 2015 or 2020 population to determine your dry weather flow. Magkukulang na yung facility or your sewage treatment plant if you make use of those population. So, after making use of your projected population, then you can now determine your dry weather flow. And then after your dry weather flow, you also determine the infiltration. Oops. Ayan. Okay. So, you also determine your average flow rate. Your average flow rate is now equal to your dry weather flow. Dry weather flow. It's this one. Dry weather flow. And then add your infiltration. Okay? So, infiltration, it may be because there is intrusion or encroachment of your groundwater table, or for example, umulan, ayan, nagkaroon ng flood and then it went to your pipe, that is your infiltration. So, that is equal to 1,483.5 that was computed a while ago. It's this one. Oops. Okay, it's that one. And then add that one to your infiltration. Your infiltration is equal to 13.32. Where did we get 13.32? It's here. So, from the table that is provided by Metcalf and Eddy, a possible infiltration flow is equal to 0.2 liters per second. Possible lang yan. It is assumed that your infiltration flow will be 0.2. So, multiply that one by the area or the lot area. Given yan kanina class in the first page. And then you just convert it to cubic meters per day. That's why I need to give you the book later on, because this is where you will now base your infiltration flow, okay, and other parameters. But ito lang naman ang kailangan yung kunin sa book, the infiltration inflow, okay? And then you can now add that one if you have converted to cubic meters per day, that is 13.32. You get the total average flow equal to 1496.82 cubic meters per day. So that is now the flow that will now be conveyed from your sewerage and drainage pipes into your wastewater treatment facility or your sewage treatment facility. So, the first part is to design your grit chamber. Your grit chamber, ilagay ko na lang lahat. Ayan. So, your grit chamber should have an area, okay, that is represented by or annotated by A sub G equal to the flow that is now passing through your grit chamber divided by the velocity. Okay? So, you know the flow, the incoming flow, kaka-compute lang natin yan kanina class. You know Q, you need to determine the area of your grit chamber. And then you need to determine also your velocity. So, let's assume that your velocity, ay ito pa pala. Okay, I'll give you a table of the velocity later on. The permissible velocity, okay, entering your grit chamber. So, this should be a given. So that you can now determine the area of your grit chamber. So, you know Q, you know V, then substitute, you get the area. So, Q is the discharge, AG is the surface area of the grit chamber and V is the velocity. Now, um, an important thing to consider when you are designing for your sewage treatment plant, kahit power yan or channel yan, okay? You have your so-called freeboard. So your freeboard accounts for a sudden or an impulse, okay? Pagka nagkaroon ng additional discharge in your facility, okay? That is the use of your freeboard so that it can accommodate that extra, okay? That extra flow. Okay, so if we continue the solution here, sabi ko, substitute lang class, and then you get the area of your grit chamber as equal to 0.577 meters squared. Now, using a square section, it really depends on you whether you want it a square, you want it rectangle, you want it heart section, pwede class, you want it parabolic, okay, kahit ano pang shape ang gusto nyo, you can. You just have to assume that a certain length or width will now comprise your area of the grit chamber. And then by assuming that it is a square cross-section para madali ang computations, I can say that for the area of E squared, that is just S squared or the sides. Okay, if this is S and that is S, then that is simply S squared. So, I want to make my computations easier, so I'll just say that the length is equal to the width. That is a square, so the area is equal to W squared. So if I have now the area here, and I am looking for W, I can just take the square root and I get W, right? Or the width of my grit chamber. So let's do that. Okay, so we get W equal to 0.76. Now, it's not good that you say, okay, so let's use a width of 0.76. No, class. Please make it easier such that when we now implement the project, pag andun na kayo sa construction, alangan naman mag-measure pa si foreman ng 0.76. Okay? So, you make it easier, you just say that the width and the length should be 0.8 by 0.8. Okay? So that is now the dimension of your grit chamber. Okay, so there, it just summarized the dimension of your grit chamber should be 0.8 by 0.8. Okay. Oops. Okay, so you know that it is now 0.8 by 0.8. Ang pangit. Ayan. So, this is 0.8 meters by 0.8 meters. Now, sabi, dapat should have a rebar in between. Oops. Okay, so the number of rebars you need to determine and the spacing in between those rebars. Okay, so bar size, you will define what is now the bar size, what is available commercially. So if you want it 12, you can make it as 12. If you want it as 15, okay, pwede din. And then if I want the clear spacing should be 5 centimeters, you will also indicate, okay, whether what that spacing is. So we need to determine the number of bars. If we use a 13 mm bar, and the clear spacing, that is the spacing from bar to bar, or this one, okay, that is 5 centimeters. Then you use this formula here, where N1 is the number of bars and N2 is the number of spacing. So I need to determine N1. So the width, that is N1 multiplied by the bar size, and N2, that is now the clear spacing. So we need to determine N2, which is now the number of bars in the grit chamber. So N2, if we have computed it properly, will now give you 12.9 spaces, or that will now give you 12 bars. So pagka meron kang 13 spaces here, class, it follows that you should have N minus 1, that is 12 bars. Okay? Okay, so that is for your rebars. And then, we now go to your primary clarifier. Class, we're just designing the dimensions of your clarifier, your grit chamber, because all of these specifics, for example, how much BOD or how much TSS is now removed from the wastewater, trabaho yan ng sanitary engineering, ng sanitary engineer class. So, your work, okay, just an introduction, is to design the dimensions of your tanks, okay? So, for the primary clarifier, you also indicate your freeboard. Now, your freeboard, you have to take into consideration the economic aspect kasi kailangang, ano yan, class, palitada. Hindi naman pwedeng hollow blocks lang. So, if you have a taller or a bigger freeboard, then of course, mas malaki yung cost. Okay? So, dapat your freeboard must be appropriate with its purpose or its function. So let's say that the freeboard is equal to 0.45 meters and then the detention time is 2 hours. I'll give you this one anyways when you do your plate. Okay, so the detention time is given, that is 2 hours. Or when you convert that one to days so that we have consistent units, you get Q equal to, or you have Q that is also given, that is 1496.82 cubic meters. So you know that Q is equal to A over V, or that is the area divided by the velocity, or that is just equal to volume divided by your time. So if I want to determine the volume, since I want to determine the dimensions of my tank, I need to determine the volume. Okay? Hindi ko kailangan ng discharge sa pag-compute ng dimensions. I need the volume. So, you have Q, you have T, so you can already compute for your volume, that is 124.735 cubic meters. Okay? If you have substituted it properly, then you get this value here. After getting the volume, okay, so after getting the volume, a while ago when we designed your grit chamber, we assumed a square dimensions, right? But when we are talking about your volume, pagka volume ng pinag-uusapan, for example, your sedimentary tanks or clarifying tanks, sorry, then you need to assume first your surface wastewater depth. So for example, ito yung tank. It's rectangular to make the computations easier. This is the surface level here. Okay? There. What you assume, okay? Kasi hindi naman pwedeng you dictate it according to what you want. You dictate the depth according to the availability of your area. Okay? So pagka hindi problema ang area, okay, you have a lot of area, then it's okay. But if you have a limited area, you need to budget your tanks or the positioning of your tanks so that you can now maximize that area. So for example, let's say that we have a surface water depth, the maximum that it can occupy, wala pang freeboard dito, let me draw, is this one. It has a depth of 2.5 meters. So assume a depth first. So let's say that we want to determine the length and the width. Ito nang hinahanap, the length and the width. So I know, or I have assumed that the depth is now equal to 2.5. I just need to determine now my length and width. So you know the volume a while ago, that is 124.74. Okay? Natin yan kanina. So to solve for a volume of a rectangular box, that is just length times width times height. We know that we know the height, that is 2.5. We don't know the length and the width. So we can assume that your length is 1.5 of the width. So oops, we have 10 minutes. So you just substitute, you just assume that your length is equal to 1.5 the width. So substitute here, and then you get the value of your width. After getting the value of your width, you get the value of your length. And then again, class, do not say that your tanks will now be 5.77 or 8.66. Okay? Round it off to the biggest whole number. So for example, 5.77, say that the width is now equal to 6 meters and the length is now equal to 9 meters. Now, when you are designing, it's not good that you only have one design. Iisa lang, you do not have an alternative. So, you can also have another depth here. Ay, wala na. Okay, never mind. I think it's on the other solution. So, let's say that the total depth plus the freeboard, that is 0.45. Remember a while ago, I told you that the depth is equal to the maximum depth that the wastewater could now occupy. Kailangan mong maglagay ng freeboard, that is 0.45. So D, or the total depth, is equal to 2.95, and the volume, okay, we need to check. It should be greater than the volume that is now computed a while ago. So that, again, pagka nagkaroon ng additional discharge, you can accommodate them. So 8.66 multiplied by 5.77 by 2.5 will now give you 135. Anong design natin kanina? Oops. Okay, so there. So you test first with the values that you have computed. Okay? Anyways, mas malaki naman talaga yan pagka you have adjusted the dimensions. Okay. So you're done with your grip chamber. You're done with your primary clarification tank. Okay? So surface area of the tank is now equal to the final. This is now the final. That is 9 by 6, 54 square meter. Now you have to compare that one when you now draw the locations of your other processes. So your overflow rate is this one. You know that Q is equal to A over V. So you just modify that formula, and then you get the volume equal to 149.82, okay, cubic meters per day divided by the area. That is what we have computed a while ago. That is 54 square meter. So the overflow rate is now equal to 29.9364 cubic meters per square meter day. Okay, so you can now draw your clarification tank or primary clarifier, okay, this way. So a while ago, we said that the length or the width is now equal to 6 meters and the length equal to 9 meters. So pagka tinignan nyo sa taas, that is where you can see your cross bridge. Why do you need a cross bridge? So that when you get a sample to determine the efficiency of your process, okay, you can now get a sample. You need to get a sample where it is the sample is not biased. Kasi pag kumuha ka dito sa gilid-gilid, okay, the sample might not represent the whole or the efficiency of your process. So you're looking at your primary clarifier at the top. Okay, this is the top view. So if you go to this view, this is now the side view. Okay, or when you cut, if I cut here, this one, you get this view over here. So you have a cross bridge, and then you just put the dimensions of your clarifying tank, and then by virtue, you should always have two chambers. Okay? So, dalawang influent, you get one pipe here and another pipe there. Okay, so that is now the design of your primary clarifying tank. Parang hindi kita. Okay, wait. Let me zoom in. Okay, I think it's this one. So, here, your freeboard, and then your depth. Okay? Para makita nyo lang. So, we can now go to your activated sludge tank. Let me just erase. So, we have 3 minutes. I think I'll end the lecture, the second part of the lecture here, so that we can go to the design of your aeration tank. Last na to, class, so please come back for the third part of the lecture. We go to the design of your aeration tank. Okay? So I'll end here para hindi maputol yung discussion later on. Okay?